Assalamualaikum warahmatullahi wabarakatuh. So today I would like to explain about lab 4. So my part is part A. So first you have to read the procedure first. So the first thing you have to do is make sure the spring constant at default, and the damping to none. The gravity is also at default. And so first you have to measure the length of spring. So put the ruler there and you tick at the displacement. You have to, so you can get the length of the spring without the mass. So that's for the length of spring without the mass. So second is put the weight. As you can see from the table, you have to you have to take a three reading from 50 gram to 300. You have to take 3 reading. So first tick at the movable line, and you can have, and also movable line, you can drag the movable line to end of the spring. You have to put the measurement is, and put the ruler there, and you get the measurement. You have to do it 3 times because in the table we have to record 3 reading. Okay, that's all for the first one. For the step first, you have to do it till 300 gram. So table have the integral. You can pause the elongation here. You can get the elongation. So for the time taken, you have to take the stopwatch. And time taken, if you drag the mass is from here, for the rest you have to do it there also, from there. So pause. So for the first mass is 50 gram. You drag this on the stopwatch. The oscillation is 25, so you have to count to 25. If that is too fast, you take the slow, put the mass back, drag to the down there, and start your stopwatch. Okay, this is one.
So for the part B of the lab, it is the pendulum lab. So firstly, we are going to set up the simulation as already stated in the procedure. So now we are going to set the length of the string to 0.1 meter and drag it to 50 degrees and play the stopwatch. Next, we are going to count the number of oscillations until it reaches 25, and we are going to record the time taken. So once we are done with this part, we are going to fill in here the table given. So the time taken for 25 oscillations is measured 3 times and recorded in a table. After that, the average time taken for the 3 measurements is calculated and also recorded. Since the length of the string varies, this whole step process is repeated using different length of strings, which is 0.2, 0.4, 0.6, 0.8, and 1.0. To calculate the periodic time for each length of spring, it is given here the formula, which is the average time taken divided by the number of swings, which is 25. To calculate the time squared, it is the periodic time for each length of spring squared. So once we are done filling up the table, we are going to construct a graph. So the graph is constructed using Excel, and the title of the graph given time squared versus length of string in meters. Once we have already draw the graph, we can see that the length of string is directly proportional to the time. So we can say that the longer the length of string, the longer the time taken for 25 oscillations. To calculate the gradient of the graph, we have already calculated it using Excel, and it is found that the gradient of the graph is 4.1. So that is all for part B.